Here we have some metal halide HID lamps, HID standing for high intensity discharge, which in itself is a family of lamps that produce light by passing current through a gas like a fluorescent, but at high intensity. The arc itself produces enough light to actually be usable as a light source. So unlike a fluorescent, they don't rely on a phosphor to make the actual light. They can generate the light in the arc itself. And HID entails a basic family of mercury vapor, metal halide, and high pressure sodium, and also XMH xenon metal halide, which will be covered here too. But this particular lamp here is the most common. It's an ordinary Philips 400 watt universal burning metal halide lamp, MH400/U. And this particular lamp can burn in any position. And you can see the arc tube in the center. It's made of quartz and it runs at about 50 psi pressure, which is pretty high even for an HID lamp. And that's how it allows it to produce high light output. The predominant discharge is through mercury vapor, and there's halide salts, and that's what's clouding up the arc tube, that vaporize into the mercury vapor to produce the white color that metal halide lamps are known for. The color is around 4,000 Kelvin, so it's pretty white, almost like cool white fluorescent. How the lamp works is inside the lamp, the outer envelope, you have an arc tube, and it's made of quartz, and it's sealed on both ends. As you can see, there's an electrode on each end, an operating electrode, which is just a coiled piece of tungsten. Can't really see it, it's way up inside there, but and also there's a starting electrode and starting resistor, which helps the lamp start when it's cold. When the lamp starts, initially the arc is through argon gas. The lamp is very dim at that point, and the discharge fills the whole arc tube, so the lamp's very dim and it glows a blue color. As the lamp heats up, the mercury starts to vaporize first. The arc gets smaller and brighter, and it's still blue, still the color of a mercury discharge. Then enough heat is made to start vaporizing the halide salts, which are various chemicals, and each one gives off its own color. So when they're all combined together and they mix with the blue color of the mercury vapor, as they vaporize into the arc stream, the lamp starts to shift from a blue color to a white color. And the reason why the ends of the arc tube are white, they're coated with ceramic to reflect heat back into the lamp that would otherwise be wasted, to keep the arc at a specific temperature, because some of the halide salts need a certain temperature to stay vaporized. If they go below that, the lamp will shift in color. So by painting the ends white, it keeps the temperature in the arc up so that the lamp maintains its color. This 400 watt lamp puts out about 38,000 lumens, which is quite a bit more actually than a 400 watt mercury vapor, which puts out about 20,000 lumens. So it's a little more efficient than a mercury lamp. Not as efficient as a high pressure sodium, which is about 50,000 lumens. But the lamp is right in the middle and it has white color. It has a reasonably long life, although shorter than mercury vapor and high pressure sodium. And the lamp has the advantage that the coloration of light is very clean and crisp. So they can be used both indoors and out, which is a nice feature of these lamps. And the average life of a lamp like this, if it's burned base up, is about maybe 20,000 hours. Horizontal, probably about 10,000 hours. Because when you burn them horizontally, the arc bows and heats the quartz more. So the arc tube will melt after a while and cause early failure of the lamp. These particular lamps are commonly used for high bay lighting and parking lot lighting and underneath gas station canopies, things like that. It's a very common lamp. It's an older lamp that's unfortunately slowly being phased out for pulse start MH, which is more efficient but less reliable. On the metal halide lamps, this is yet another dimension in metal halide lighting. This one has a tiny little arc tube inside of it. That's around 35 watts. And this is actually the same basic lamp that they use in the headlights of a lot of today's automobiles. The cars that you see going down the road with the really bright blue or really white color headlights or HID headlights. Works on the same principle as the standard metal halide, but the arc tube's much smaller. And it's actually even at higher pressure, so it can produce even more light and it's a bit more efficient. And it has the virtues of compactness, so it can be put into a battery-operated portable spotlight like this one is. Okay, here's yet another format and another dimension of metal halide lighting. This particular specimen is kind of a rare lamp. It was put out by Venture Lighting International, which is a US company, and it was only made for like 1 or 2 years, around 1991 or 92. And it's kind of a collector's item now because they no longer make the lamp. It's in a par 48 envelope, similar to a car headlight. The fixture that it's in is a fixture I've had since I was a little kid, come from a building my dad tore down years ago. I restored it and put the metal halide lamp in it. So it's a new lamp and an antique fixture. And this one's pulse start. It uses an igniter, which is down on the bottom here with the ballast, like a high pressure sodium lamp. So it starts with a pulse like an HPS lamp, yet it's a metal halide lamp. This particular model has a shield around the arc tube to diffuse the light. And it's also there so if the arc tube explodes at the end of life, it won't blow up the whole bulb. That acts like a shield to prevent violent failure of the lamp. This particular model also has a warm color when it lights up. It looks almost like a halogen or an incandescent when it's lit. So it's a decent replacement for halogen that's more efficient. Unfortunately, the company doesn't make this lamp anymore.